Got some cool stuff to show you today. Got this thing called Blinkie lights. I talk a little bit about. It's kind of out there. It's kind of like this idea about better visibility, our network packets, and gave me an excuse to play with Arduino and play with electronics. So bear with me. I think we'll have some fun. And by the way, Q&A is fine throughout or at the end. Just if you have something to add, I'll try to get to you in the middle. Feel free to just don't throw anything. That's all I ask. By the way, at 11 o'clock, halfway through the presentation, I am supposed to tell you that the alcohol will be available, and that the talk is actually better enjoyed with a couple in you. So just so you know, I won't hold it against you if you want to sneak out. So I work for Trustwave Spire Labs. By the way, my name is Steve Ocepek. No Steve. I work for Trustwave Spire Labs. Legal department's been kind of on us because we used to do things like grab stuff off of Google Images and throw stuff in our presentations. And apparently, obviously some people copyright some of that stuff. I mean, honestly, the kind of stuff that we use, I was surprised that there was any copyright on that at all, right? But apparently, so legal says, you can't do anything like that. So, I just want to apologize in advance for the quality of some of the images, but it gets the point across. So starting right off. So this is kind of like where I came from, right? I don't know how many of you go back to the Stone Age, right, of this stuff and networking, but this was my super realistic rendition of my Supra 2400 modem, or actually Super modem. Sorry, there's no affiliation with copyright there. But so you see, there's the RD and SD. Those two lights, for those of you who didn't play around with modems, were like, they're like crack, right? I mean, they just sit there and you'd be downloading a file. You'd be really excited to get a file. And RD would be solid, and SD, be blinking with the handshake and stuff. And it was just like you had this, I can see my data, right? There's this concept that you kind of knew what the heck was going on in your machine. When I download something, RD lights up. When I was uploading something, then SD's lit, and I kind of know what's going on, right? And then it kind of goes from there. From that time to now, there's sort of this, timeline that I kind of made, and it's so we have, I just threw a couple things up there. 56K, I think that says Netsplosion, and somewhere there's YouTube, and then some other stuff happened, and now mobile. I think I just sort of grabbed as many like keywords as I could, and then the cloud spoke of cigarettes. That's why we have this down here, but. We have this big problem where basically everything's changed since then. Everything's gotten very, very complicated. When you turn your machine on and you're hitting, if you're on Skype or whatever, and you're browsing the web, you really don't know what the hell your machine's doing, right? The whole thing is that I've lost track. There's no such thing as an RD and SD. I mean, there is, right? There's this concept that there's a link light. There's like Blinkie, one LED. But anymore, I mean, if you look at netstat, if you really stare at netstat, it's like, what the heck is my machine doing, right? Netstat lists all the open connections that your machine's making. If you look at that thing, it's like, what is this? What's this? What's this? And you just eyes kind of glaze over, and you stop looking at it. It freaks you out. It's like staring into the void, So these days, right, a 2-minute PCAP generally is a larger file size than a 2-minute MP3. Just saying, that's how much stuff we got going on. And really, the state of the state of things is that you have this activity light that's just solid. It's just pegged. Doesn't really tell us a whole hell of a lot. So again, apologies to those who were depicted here, but really this is kind of the where I'm coming from, right? Is that we actually do have the talking heads who are saying that you really should start with monitoring. So this is sort of trying to legitimize this talk, really. You have Richard Beidlich who says, network security monitoring, we should really be doing that. Earlier, he referenced a cryptogram, came from Bruce Schneier in 2001. By the way, those are muscles, that's not hair, that's muscles. Just wanted you to know about that. Wasn't trying to pull a fast one there. But monitoring first, right? He says monitoring should be first step in any network security plan. It's something an administrator can do today to provide immediate value. So, but we've been down this road before. right? I mean, it's like monitoring. Okay, monitoring what? IDS, sniffers, scrapers, and this is one of those, like, I don't know, I tend to write these little mini screenplays and throw them in the trash afterwards, so sorry for subjecting you to this, but I'll try to stick with the facts here. So like scrapers, log monitors, and then, I mean, no, like, you know, what's the box doing, right? That's the whole thing. It's like IDS and IPS. That's something that's on the perimeter. It's important. We need it, right? I'm not bashing any of these technologies. It's just that there's this thing that I'm going for that's like monitoring now, real-time monitoring, understanding what's happening right now. So yeah, then you get the thing, well, we'll fire Wireshark. Well, Wireshark's, again, another void. You're going to stare into that for a while. It's great for analysis. It's great for looking at protocols, how protocols work, taking things apart. If you're going to write a program to manipulate something, I mean, Wireshark is awesome. But as far as for monitoring's sake, probably not so much, right? It's going to give you a whole bunch of data. And so I think it kind of evolved at this point. But Wireshark is for analysis, not monitoring, right? And then we can just probably move right along there. So we need something else, right? We need something like the old days. We need to get this RDSD Blinkie light thing that I used to have on my desk. I used to know what the hell's going on. But it has to be a little more complicated. It has to be a little more, there's more going on now, so we have to try to find a way to visualize this stuff, right? I wanted something that was a good excuse to play with Arduino. Of course, something that sounds good in GrrCON schedule, right? So, and something that preferably has freaking Blinkie lights. Most importantly, something that's going to give us visibility. So, what I mean when I say visibility is I'm making my own distinctions. This is sort of me just making up like definitions. It's not like you're going to look up in the dictionary difference between visibility and visualization and see this differentiation. This is just, I'm trying to go for something here, right? So just bear with me. It's something that's peripheral, right? It's something that is going to always be there. Visualization, I think of that, when people use that word, I think of these beautiful graphs full of different, colors and charts and whatnot, that are very, very interesting looking, but you have to really study them. You have to understand what they mean, right? When I think of visibility, I think of something real time. I think of something like that's happening now, that's giving me like real-time visibility into this. There's this, I know it's like a naval term when it comes to visibility, like how far away you can see, what the conditions are like. When I used to play that as a Commodore, I played the Silent Service game. It's just probably my closest stint, to having a stint in the military, right? And so they had like visibility low or visibility high, and the whole idea was, well, this is your ability to make decisions based on real-time data, right? This is your ability to see ships. This is your ability to do whatever. Of course, you turn the trainer on and blew them all away anyway. But still, you get the point. It's like basically it's your ability to see what's happening and make decisions. So my differentiation is visualization is our reasoning ability, our long-term thinking, our chess-playing ability, whatever. It's like, okay, I look at some really complicated graph and I understand I need to make a change here. Visibility is more about what's happening now. Why is that? It's because visibility taps into something called, don't worry, I swear we're going to play with this. I know this is like all really high. I have to get through this before this turns on. And incidentally, I'm going to try to put this at the halfway mark so I try to keep people from leaving when the alcohol comes out. So that's my plan. So real-time cognition is what I'm talking about, visibility, right? It's like driving. It's like the car analogy. I'm not a mechanic, but driving the car, if you hear something that's not there, you get really, really used to what it's supposed to sound like. And then all of a sudden it starts sounding different. Like you turn the corner and it starts vibrating the wheel or whatever. Go into the shop and I say, it's doing something weird, right? And the guy looks at me like I'm an idiot, right? But the thing is, I tell him, look, it's starting to, when I turn at this corner, I do a 45-degree, whatever, it makes this shaking, it's pattern matching. It's me being able to, the cognition tapping in and saying, hey, something's different. Video games are like that, sports are like that. It's a direct connection between the senses, right? So the cool thing that sounded really good was the acute perception of slight variances of stimuli. Okay, so there is some scholarly reference here. This is from Michael Spivey and Rick Dale, Cornell University and University of Memphis, who got pulled into this talk, I'm sure against their will. Real-time cognition is best described as a sequence, this is a tricky one, sequence of logical operations performed formed of discrete symbols, but as a continuously changing pattern in neuronal activity. Okay. What I take away from that, I'm not going to pretend I understand all that, but what I'm going to take away from that is, it's based on, it's really like, it's continuously changing, it's dynamic. It's something that we're going to pick up as we move along and sort of, you know, it allows us to, like I said, cognition is going to tap into our ability to do pattern matching in real time. So, okay, enough of that crap, right? Let's play with electronics. So, we've got this thing going on, right? Where's this come in? So, don't worry, I've got a movie. You guys in the back are going to be able to see this as well on the big screen. The reason I picked like a USB toy to kind of do this is because if you think about it, like the screen real estate market's tapped out. Like you see, I made my little diagram over here. You've got like the screen. Basically, what's happening is, you know, all these applications want to do full screen and they want to take up the whole screen, maximize button. You know, everybody's always hitting that, and so it's really hard. When I first started doing this, I wanted to make it an application that was always on top or something. So you'd have to tie into like OS calls to make the application always on top. This one, but you find that your focus gets clobbered pretty easily, pretty quickly. You lose focus. So I was thinking, you know, if you just put it on the desk, because you got all this crap on the desk, you have like USB, you know, Christmas trees, ninja detectors, and Nerf shooters and whatnot. I was thinking, well, if it helps you like kind of understand what's going on in the network, maybe, you know, it could sit next to those things. There's a lot of room on the desk. I figured there's probably like something there. So the crazy idea is I want to render network data onto an LED in real time, just see what happens. This is an experiment, right? Just to see if it does anything for us. We can use things like color, we can use motion, we can use all kinds of different concepts to try to like render it and make it look different. Again, it's that tactile, which isn't the right word, but it's sort of that feel for what the network's doing, right? And it's going to tap into our natural ability to detect patterns, like we were talking about with the car thing. I call it cerealbox, and the reason is it's like, does anybody like read the back of cereal boxes? Right? Is anybody? Yeah. So I get some hands. I mean, people know what I'm talking about, and it's. You know, it's like, I don't know why we read this stuff. It's like the most inane bullshit you ever seen, right? I mean, it's like, you're going to help the cuckoo bird get through the maze to like get his fix, like at the bottom, right? But you do it. I do it. I don't know why, right? Well, the reason is, I think the main reason is because it's there, right? There's a big thing to, there's something very big to say about the fact that it's just there, right? If it's there, we're going to mess with it. If it's there, we're going to play with it. If it's there, we're going to try to figure it out, and so, I want this to be one of those kind of things. It's not something you're going to stare at. It's not something you're going to study. It's something that's going to be on your desk. You're going to play with it. It's in the background. It's always like peripheral. And it's going to let us see slight variances, right? It's going to sort of feed that cognition in the background. Every once in a while we'll glance at it. It'll always just sort of be there and we'll play around with it. It's just enough info. So if all this thing does for us is give us just enough info to dig deeper, then I think that's what we want it to do. We want it to give us the idea that something is different. The board is, and by the way, they're going to be giving one of these away. I donate one of these to the giveaway. So if you go through and you do the vendor thing and you do all the whatever it is, check your boxes or whatever, then there's one of these in the giveaway. So if you want to play with it, that's a good way to go there. But they're pretty cheap to get a hold of. So Arduino Uno, for those of you who haven't heard of Arduino before. This is a little hobbyist kit you can get. It's really just that board there. The Uno, they sell different types of boards. The Uno is kind of the baseline. And it's got 8-bit RISC CPU. It's actually pretty fast for that class. 16 megahertz is decent. But you're limited because you've got 32K of flash and 2K of SRAM. What that translates to is basically that 2K of SRAM, to put that in perspective, I mean, if you go back to the early 80s and you're playing with 8-bit computers, that's even less than a lot of those guys had, right? Commodore 64 was called back to 64K RAM. This thing is really, really low end. So it's pretty cool to play with, but you got to think. I mean, it's kind of a puzzle. Playing with embedded stuff, you're kind of screwed from the beginning because you're already out of memory before you can start, just about. So. When I was programming this, it was kind of fun. I had to sit down and really kind of go through, like, how big is my data structure or whatever, and do all that old school stuff to make sure I can fit it inside this limited amount of space. It is USB powered, and you can communicate with it over USB. For those hardware heads in the audience, there is no hardware handshaking on this thing, if you know what that means, which is kind of insane. If we're in like 2011 and we're talking about hardware handshaking, so something's terribly wrong. But hardware handshaking basically is the ability for it to kind of on the wire tell you whether it's received your data, tell you how much data it's received, sort of to make sure that your data is getting across the wire. It doesn't have that, so you'll see we kind of ended up going a little slower on the speed to make sure it's still working, because we're kind of afraid of losing data. But it has a great reference manual. It's $30. We're almost there. Bear with me here. Arduino Shield. So these things. You'll see this, or you can come up after to get a better look, but there's almost like a sandwich thing. You've got at the bottom, you've got the Arduino Uno board, and there's this little thing called a shield. A shield is like an add-on board. If you see the word shield, it's an add-on board for the Arduino, and basically it fits onto the pins. The pins go into the headers there, and then what this is a controller for LEDs. Now if you look up, like if you go to YouTube and you do Arduino LED, and you just type that in as your keywords, you're going to see a lot of videos of people playing with this stuff, and they're going to have like a breadboard, and they'll have a lot of wires crisscrossing and stuff, and going into the LED and programming it, basically sending it signals on the fly. What this thing does, it makes our lives a lot easier for people like me, not really much of a hardware hacker. This thing makes it easier to talk to the LEDs. So there's a library that comes with it that allows you to just sort of talk to this thing, and this chip that's on here controls the LEDs fairly easily. We're looking at about $66 if you want to build one, which is pretty cheap. I mean, that's not too bad. I mean, it's hobbyist electronics. If somebody cranked these out of some, if they mass produced them, it'd be a lot cheaper. But for hobbyist electronics, it's not too bad. So if you're going to program something like this, really it's about trying to make sure the design goal is to keep it as simple as possible. I want to make everything as stupid as I could, right? I wanted to make the program really easy. I wanted to make the program that's running on the Arduino very easy. Minimal data retention. We only have 2K of SRAM, so we only have so much to work with. And honestly, if I'm doing something with a sniffer and I'm going to render it on there, I can't be packet-based. If I'm packet-based, it's going to be a fire hazard. Things can explode, right? Because there's going to be so much data that's coming out of my machine. It's basically going to be way too much for this link to handle. So we took it up a notch, and it's like session-based. So think about TCP and UDP, right? That's the layer we're on, because that's the most effective. If you've got basically 64 lights to work with, then you're inside of the range where it's basically like, okay, yeah, I can render that data effectively. MAC address, what happens is the sniffer's going to gather this information, it's going to send this over, MAC address, IP address, TCP port, or UDP port, country code. We'll see where country code's pretty interesting here in a minute. And then we're going to get into the language. So actually, you know what, I'm going to break out of here and see if I can show you this stuff. I think I'm skipping some things here. Let's actually look at one of these. First of all, what I'd like to do, if the demo gods are happy today, I'd like to show it to you in real time, and then what I've got is a movie, I can show it on the screen. Here, hang on 1 second here. So what I'm doing here is, it's a sniffer. Something to keep in mind, there's the Perl script, there's two pieces of it. There's a Perl script, which is this CBPL thing here, that's going to run on your box. It's the sniffer, it's going to feed that guy. And then on the other side, you've got the Arduino code running on the actual board. So what I'm doing here is, I'm going to fire up this Perl script. All it is you're telling it which interface you're going to monitor, which IP you're going to monitor, and then the actual COM port, the actual serial port. So on the Mac, it's going to look like that. On the Linux box, it's going to be like dev, TTY, USB, something. On Windows, it's going to be like COM4 or something like that. So I'm going to go and run this thing, and then what's going to happen is what I have is PCAPs here. So it's a sniffer, so I'm just going to feed the card some stuff. I'm using TCP replay to feed the EN0 device some stuff. Actually, I'm going to save Port Scan here for a minute. Let's do browsing. And what's going to start happening is this little guy's going to light up. And again, I'm going to show a movie in a minute, so don't worry if this is like teeny tiny to this in the back. But what's happening is, every time there's a new session, it's sending over, see those commands up top there, it's sending those over the serial link, and for each open session it's creating a light. Now the light is color-coded based on the country. The way that that actually works is that we're converting country codes to RGB values on the fly, just using the ASCII values of the country code. So it's like using what's called pseudo-random seed, which is kind of handy because it's something that it's going to always be the same. It's not really random, it's pseudo-random. So it's always going to be the same, but that allowed us, remember, 2K of SRAM. I don't want to load a lookup table in there. So basically, without having to retain data that, US equals green, and so equals red. And by the way, you'll see, I can't even tell you what all the countries look like. You kind of have to, look at what's coming out of here and figure it out. But some of them are red, some countries are red, and it just kind of worked out that way, and it actually was kind of apt, I'm just saying. So you'll see what I mean. But so that's the live demo. Let me show you the movie here. Get on the big screen. There's two views we're going to look at. This is what's called the session view here. So here we go. And I think I did some zoom in. Yeah, I did some zoom in things. So this is me loading it on the board. Okay, this is the Arduino IDE. This comes with its free download. Actually, you just download it off their site. And there's that little button up there that says upload. So once you're done typing all your swirly code here, you upload it, and it goes onto the board. It compiles the program, puts it in flash memory, throws it in the board. So this is all free, by the way. I should have said that up front. It's on our GitHub site. It's all free. You can go download it, play with it, make your own, do whatever you want with it, and hopefully make it better, add to it, do other things, get creative, whatnot. There's the Perl script on this side. Again, you could make your own program to do this, and there it goes. So now, what I did is I had this really old video camera. These were really hard to film. I had a different LED here that I was using. They were very, very hard to film because they were so bright. But this one allowed me to turn the exposure down. So basically, I've got that going on. I think I'm going to zoom out here in a minute. And what you're going to see is sort of the correlation, right? This is the correlation between what I'm doing on this side. I'm browsing and doing stuff. And then, you see, there's that whole RDSD thing. There's that whole Supra modem thing, right? Where I'm doing something, and I see it. I see something's happening. I see I'm going to make more connections. So then I click on a link, and boom, a bunch of stuff's going to open. Right? I go to Wikipedia, a bunch of stuff opens. Some stuff closes. Right? Stuff's closing because the older stuff that I was visiting, they keep the connection open for maybe a minute or 30 seconds or whatever, in case I want to pull down more images. Those are going to close down, and then the other stuff's going to open up. And I think here, Demo Steve here is kind of waiting to show us that these are gonna all go away if we just sit here and we don't do anything, right? Because those connections are eventually just gonna die because we're not pulling down any data. There it goes. So there's like one left, right? There's gonna be like one or whatever. You'll identify sort of your long-running sessions that you're used to along with the other ones. Okay, so now here's the really cool part. This is like the awesome part of the whole presentation. I go to BBC UK, and then it's like blue, right? So like, I know you're like, why the hell did I come to this talk? The big deal is like it turned blue, right? But that's like pretty exciting, right? Because I'm going to a different country site and I've got like a blue light, which is like, wow, that's interesting. So now I can tell, this is what's really fun about this thing. I got like really attached to it. And I mean, my wife's kind of frustrated because I bring it to bed at night, it's like, it's kind of got sharp edges and crap. But the thing is that the Skype is really super chatty, right? Skype is like insane. You see all kinds of connections. You learn all sorts of stuff about your machine when you use this thing. And what's fun is you actually see it. There's a correlation between the people who are using Skype and what you're doing. So, like, we're a global team. So I've got a couple people on my team, like my buddy Rodrigo lives in Brazil, lives in Sao Paulo. And there's that thing in Skype where it says Rodrigo is typing. There's that notification message in Skype. And so I was like, oh, Rodrigo's typing. But before even that happened, I saw on here the color for Brazil, which is magenta, happens to be magenta. The color for Brazil pops up, and I see a magenta light. I'm like, oh, Rodrigo's about to send me a message. And bam, Rodrigo sends me a message. It's like, oh, that's pretty cool. And same with like Tom McKenzie in UK, another friend of mine. I'd see a blue one show up, completely just sitting there. and not doing anything. And then, actually, I'll tell you about this in a second. And then I'd see blue on there. This is kind of cool. This is another thing. See how this thing's blinking like crazy? And then there's some Google Maps stuff. I'm just doing a whole bunch of stuff up there. But let me rewind here because I was yakking. This guy. So this is another thing. You learn about stuff. So, okay, check for updates popped up. I think right while I was doing this demo, I was just like, okay, well, let's just see what that looks like, right? So it's just going crazy. What it's doing, what I noticed about the behavior of that program, about the updater, is it just makes a whole bunch. Look at how those things are going up. It's just making a whole bunch of connections to the server. I don't know why. It's like every single update or something, it's firing off into the connection. And it's closing it right away. So that's why you get the blink. You get open, close, open, close, open, close. And then, maps, we can see what that does and whatnot. So it's just, you'll find yourself playing with it, learning all sorts of stuff about, kind of how it works, which is pretty fun. So that's one of the views. That's session. I'll throw some other code at you here, and we'll go to the next one. This lets us control the LEDs with a simple protocol. This is, I don't even know if I want to call this a protocol. It's not that complicated, but basically this is what I had to write to talk to this guy in real time. There were a lot of demos, a lot of demo code online on how to pre-populate Arduino with code, with like information, and then render it on an LED. But what I didn't find was somebody talking to it in real time. That's unusual. The whole like this thing we're doing that's updating it like instantaneously. So I wrote this thing where really it's very, very simple. It's 1 is open, 2 is closed. We're throwing the MAC address in there. I'm not even using that yet, but I figured throw it in there because it would be interesting to know if you're talking to local link or if you're talking to the gateway or whatever. You want to make a local LAN version of this. You can totally do it with this data. IP address in hex, port number in hex, and then country code. That's really what it is. It's using GeoIP plugin, in this case Perl. I think it's MaxMind's database to do that, which is free as well. This stuff's free. The code is available on GitHub. Basic C, so for those of you who want to start coding, which would be awesome, certainly talk to me afterwards if you're interested in coding some of this stuff. If you want to write stuff for the Arduino or expand on this idea. They've got a good reference manual on the Arduino site. It's basic C. It's very basic C. So it's like stuff like this where I sometimes get to where I get all like full of myself and I think, oh, back in the old days, programming C, it was so much simpler and so much better, and Ruby and Java are too high level, and you're losing all these cycles, and I talk to registers, and everything sounds real great, right? And then you have to sit down. It's like, okay, Rockstar, you got to parse text, and so it's like, oh shit. So yeah, it's full of this code's just full of stuff like this. A really good C coder would probably look at this and just crap all over it. But it's and like I was saying, somebody could probably like pwn your cerealbox or something. There's probably a buffer overflow or something in there. But try to be careful about that. Who knows, right? But it's a good POC. And what you're going to see is like basically, yeah, when you're on this level, you don't really have very good string processing functions, so you actually am reading data in one byte at a time and saying, is it this, ASCII values, and whatnot. So there are such, you can do hash tables in this, but they're not native. It's a hack. Like I say, it's a subset of C that runs on the Arduino because it's pretty low power. But you basically got arrays and for loops. That's what you're going to be doing a lot of in that world. There's a library by this guy named Blinkie that is, so remember I was saying it's kind of a sandwich, that shield that's in the middle. So it's like the Arduino, the color shield, and then the LED. So the middle of that sandwich, the color shield thing, there's a library for that. It's called the Colorduino Library. It's by this guy Blinkie. It's really cool because it lets you do stuff very simply, where you see like Colorduino.setPixel, X3, Y8, and then those last three are RGB values, so red, green, blue. That's it, right? That's how you set pixels. Then you do flip page because it's got a frame buffer. Then down here you can also do it using a pointer. So if you just want to increment, like you could do P++ there. You'd say that red is 0, green 0, blue is 255 on that, like 3.8. If I wanted to go to, I guess it'd put me at 3.9. I think if I did this. I can do P++ there to go to the next one. I might be wrong, it might be 4.8. We'll see. But this is that thing I was telling you about where I sort of made the country code RGB. basically this is the way of doing that. So ASCII value is random seed. You'll see it in the code if you want to look at it, but kind of interesting way of getting around that attack, that problem. So apologize for that. Actually, that's what happens when when you try to take pictures of the LEDs, and that's why I use the camera to do that. And so basically, yeah. But just so you know, I mean, expect to get, you see how many lights are lit up there. Expect to see some really interesting things when you start using it with Skype and whatnot. The data storage stuff, there's, like I said, I want to make it as stupid as possible. There was only so much RAM, so like, I figured out, again, I had to do the math, so 128 entries was about 1.2K, right, which is like bloatware, right, in like an embedded world, my SRAMs. So that's where what you get is you actually get 128. So what you'll see is, and I'm not sure if it's done it yet or if it's going to do it, I think I need to fire off something else. Yeah, actually it's doing it now. You see how it's flickering back and forth? It's like, you'll see one page and you see the other page, and it's kind of going back and forth. You actually have 128 lights, sort of, because what it's doing is once it gets past the initial 64, it'll go to the next screen. After that, if I was going to add another 64, I thought that might get too confusing, and plus there's only 1.2K. I'm already at 1.2K with that, so I had to have put my other stuff in there. But you've actually got 128 with it. You get, hardware hack or something, you can probably expand that, put a bigger LED, more LEDs, whatever. This is just some fun stuff for the C coders in the room that to try to figure out if this makes sense. This is the multi-dimensional array that populates the LEDs. So basically, there's actually, this is what this stores multiple. This is actually the data structure. So the 0, 1, and 2 slots have the RGB values in them. There's this array called LED, and then each position on there contains this data. And then down here we're doing IP. So all that is that's IP address, this section, the second section here, the third section's port. That's all it stores. The reason it stores that though, and you see, like I said, I want to be as stupid as possible, but I couldn't leave this data out because when I say close the session, right? When I say close the session, it's basically, it needs to know where that session is and it needs to be able to close it. Okay, let's do another demo. Those are more fun. Meter mode. So this is just throwing ideas out there, thinking about different ways of visualizing the data. So this one, think about like your stereo system in the 80s when people got really fired up about like showing the notes, the treble and the bass and whatnot. Actually, you know what, I'm going to do it the same way I did before, where I'll show you the real one, and then I'll show you the demo real quick here, just to make it feel a little more legitimate. So here's what I'm going to do. Go up here to meter, so I've got them already open. This is the Arduino IDE. I'm going to upload this code. So this is a different one. You've got cerealbox over here. This is the session one. And I've got the meter code over here. So I'm just going to hit upload there. And hopefully, so let's see, it's resetting itself. It's compiling it, and then it loads it in Flash. So now, notice what happened. Immediately, it changed. Like the whole output changed. Again, this will be on the big screen, don't worry. But you've got different colors along the bottom. What those are going to be is those are like our little equalizer view. So the here we can cheat here. These are the different colors. So red is like web technologies, 80, 443. I think 80's in there as well. DNS is blue. Remote protocols like remote desktop and SSH and things of that nature. Telnet are going to be, what is it? The blue. We got green. Mail protocols are the next one over. Not to cheat here. That one's yellow. And then we got purple for file protocols like logging into your domain server. I put all the enterprise kind of stuff on there. And then under 10 is like a catch-all for stuff that doesn't match these other ones, but it's under 10,000. And over 10 is like over 10,000. That's a catch-all for anything else. Local is the only one where it's going to also fire in addition to these other ones. It's everything's either going to fit into one of these categories, or it's going to be local, but it can also be local. And local means it's on your local net. It has an LL country code, which is basically local link. I just kind of made that one up to have that in there. So I'm also going to add something that says DNS here. There's a flag you can set for the Perl script called DNS that's actually going to cause it to show DNS. By default, if you're using the session view, I would not recommend using DNS because it's going to fill it up really quick. There's so much DNS traffic. But as far as like on this mode, it makes a lot of sense. So let's do the same PCAP again using this. And so again, this was like, you know, a whole stage of my life where staring at stuff like that looked like this, you know, where you know, you're watching the music, right? That was the whole thing. That was really cool when this came out. So we got, you know, some web, we've got some DNS firing up, and then you see when DNS spikes, that white thing is spiking. I'll show it on the big screen here in a second. The white thing's spiking because DNS server in this case is on the local network. So it's firing up. So again, just another way of looking at the data. And then let's go back over here, take a look. So we already did this part. There's that stuff. There's me firing that up, and okay. So color's a little off on the screen, but it's the same colors as what you're looking at there. So yeah, stuff's starting to fire. And then the same kind of thing, I'm kind of browsing around a little bit. Now something's about to happen here, and this is sort of the big clincher, right? So if you stuck around long enough to see this, hopefully this is sort of the security application. I think there's an inherent security application in this just by staring at the data that you're able to sort of, now you kind of understand what your link is supposed to look like, and you're able to understand what, you know, what normal looks like, right? That's the whole idea, show what normal looks like and get that sort of feeling like this is what my car normally sounds like, that whole broken analogy or whatever. So then from here, what's going to happen here in a second is something bad is going to happen, and we're going to see how much different that looks. So now you've sort of gotten used to what it looks like. Let me spare you some of the other browsing things. And okay, there's some interesting stuff going on. There's Skype. I think Skype comes in. I want to show you some of the other colors, just that the colors worked. You see there's some under 10, over 10. Some of these are firing because that's Skype. Skype uses all kinds of different ports, so you're not going to see it called out in one of the normal ports. You're going to just see a whole bunch of these guys on the end firing up when you're using Skype with the meter mode. So just to give you an idea there. And then there's a remote desktop session. That one fired up as the green started hitting here. So again, just to give you another data point. And I know you all appreciate I don't have a CA there. It's really it's very secure. And then let's do this one. So now something weird happens, right? You're at 2 o'clock in the afternoon, the food coma's kicking in, and you look over and somebody comes over your desk and they're talking to you, and you're like, what the hell is your blinky lights doing? And you're like, holy crap, what is that? It's pegged. What the heck's going on, right? And this is the part where you like stand up and you're like, something's wrong. I don't know what it is, but something's wrong, right? The whole idea here is that somebody could do that. It's not even a network. It's not even network savvy, right? I mean, a lot of us in the room, we understand this stuff. We understand how it works. We're turning people into almost like a human IDS at that point, because if this is going to freak them out, what this is a port scan. What we're seeing there is basically a port scan that I kicked off up here. You see like there's an Nmap up there. And then this thing comes down and starts freaking out, right? So that's kind of the whole thing, is giving people that concept, hey, something's different, something's wrong. And we're not calling it out as wrong, we're just giving them visibility, right? That's that whole thing. We're just giving them visibility in the fact that a port scan looks a lot different than normal network traffic, right? A port scan looks very, very chatty, so let's show that. And that's kind of the thing, right? So now we've got something, my favorite part. Before I do that, real quick, performance considerations. I'm doing 9600 on here, for those who care about that kind of thing. That's about 1200 bytes per second. 32 byte message size. So again, this is that whole thing that's fun about embedded. You have to really, really think about stuff before you do it. I figure we could probably get about 32 messages. The only reason I'm going so slow with this is because it doesn't have handshaking, and it's kind of a limited system. But the thing is, the reason that comes into play is because we're limited to 128 connections. Like that first view I showed you with the sessions, we have 128 connections. I wanted to have something that was kind of like a freak out mode, right? I want to have something where it's like, especially in the session view, where it'd be like, whoa, something, you know, preferably something psychedelic so you can at least like kind of get a kick out of it, you know? But basically you need to have something that throws the hands up and say something that things are getting completely weird, right? So, so this is this thing I have, it's called overload detection. It's built into the code. It's built into the Arduino code, and what it's saying is you're basically setting a ceiling on events. So what it's doing is it's saying, I defined it at 90 events, it throws mode 9 pretty quick, and then it'll back off of that over time. But basically if you get like over 90 connections within that window, I think the window is like 5 seconds or something like that, then it's going to freak out on you. You can change that number, do other things with it. So let's go for video number 3 here. Close to the end of my time. Okay, so what I'm basically doing there again, it's running the Perl script, and then from another machine, on that other tab, from another machine, I'm going to do an nmap. And this is just ports 1 through 5, 615 through 5, just all the way up. And there it goes. And up. Something bad. So, yeah, that's kind of the the high point, right? That's something that's it actually showed up. So yeah, I mean that's the fun thing about playing with this stuff. You can get real creative. You can throw stuff at it. I didn't do the plasma, by the way. I did do the frowny face though. That is my artistic rendition. The plasma code comes from a long time ago. It's basically been handed down for a while from different graphic demos. Somebody, I think the guy who made the Colorduino thing actually ported it over to this, which is really sweet. So that's the thing. Again, the controller code, it's just Perl. It's using that PCAP. It does work in Snow Leopard. Sometimes there's some problems with that PCAP in Snow Leopard that I was able to kind of work around. So if you're looking for a solution, if you know what I'm talking about, like you'll know exactly what I'm talking about if you've run into this before. Look in this code. There's a way to set the timeout value to actually work around the problem that Snow Leopard has the PCAP, which is kind of cool. By the way, I am releasing something here. I'm going to release the Win32 version of this. So one of the big things that was problematic when I did a similar thing at DEF CON was that the Perl code, the controller code, wasn't available for Windows. It's Perl. I mean, technically it is available for Windows if you want to compile the modules, go through all the crap. But I sat down before I came out here and I got it working in Windows. So I got an exe. I swear to God, it's not malware. Even though it's associated with GrrCON, right? But you can use any IP, not just your own. This is another thing I didn't bring up last time I did this. It's a sniffer, right? So think about other ways you could see. This is kind of fun because you could be like, okay, I know what my machine looks like. I'm used to what my machine looks like. What does this other dude's machine look like? So you could do like art man in the middle type thing on somebody else, some good friend of yours at work, right? And see what their machine looks like, and then maybe start detecting other things. All you have to do is plug in their IP instead of your own IP on that Perl on that line where we were putting in the Perl script. Just make sure that you've got visibility in that traffic. You could also put it on a tap and just basically put an IP in there, just to see kind of like what everyone's machine looks like, and you might find that. Okay, I'm used to what this image, like if you're an IT administrator, I'm used to what this image looks like. This image generally looks like it fires up this one line every once in a while, or it has a certain amount of sessions. And then you look at another image that's been maybe compromised and it's doing something really weird, and you get that visual feedback. So again, it's just throwing stuff at the wall, see what sticks, right? It's a proof of concept, kind of see if we can sort of. If you walk away from this talk with nothing else, just think there are other ways of looking at data, and we need to have better ways of looking at real-time data, right? That's sort of what this is about. But it has to be something that we can ingest as human beings, right? It's a big part of this. It is simple logic, that stuff that integrates, basically just using GeoIP. Again, the Perl script pipes the data over the serial And then it does do TCP and UDP. UDP close, those of you network people in the audience know that UDP doesn't actually have definitive close or open unless you know the protocol that's being used. So there's a timeout associated with it, sort of like how firewalls work. You can make your own. I want to stress this. Take the code, tear it apart, tell me how bad it is and make it better and all that stuff. I mean, that's awesome, right? Anything you want to do, you want to make a Ruby version, you want to do whatever, you can use the serial protocol that's already on there. You don't have to be an Arduino hacker. I'm not even going to call myself an Arduino hacker, but you don't have to know, really how to do this stuff. You can just use the protocol that's already on there to make it do things using your own protocol if you just want to write it on the host itself. Other ideas, there's this thing called Ethernet Shield. I kind of think that this is one of those things that sounds really cool and is just a bad idea, capital B, capital I, because we're talking about 60 megahertz board that's probably going to totally DOS your system if you try to send traffic through it. So I don't know if that's worth looking at, but it's just interesting to know there are things like that for Arduino. There are more powerful Arduino boards as well. So there's such a thing as an Ethernet Shield. You can actually make a native sniffer there. Better host side program, more data. Right now I've got kind of this just debug data that's console based. And of course the big one is of course bigger LEDs. Next year maybe come up here and that could be the LED, right? And I just pipe it all up there, so it'd be kind of cool. The links, GitHub, Spire Labs, there's a Spire Labs site. You want to check that out if you want the code for this. Again, it's called cerealbox. There's a bunch of other links up here, the Colorduino Library that Linkomatic wrote. Untitled is where you buy the top two things, that board, the Colorduino board, and the LEDs. That's where I bought it from this company called Untitled. Studio, Arduino Uno, you can find those quite a few places, and there's a program reference link up there. So some good resources. So anyway, I'll leave that up. Any questions? Any other ideas? I just get completely freaked out by all this awesomeness. I know it's first time you see it. Yeah, go ahead. Question is, have you ever thought about feeding log data? That's a great idea. Sure. Absolutely. Yeah, absolutely. Different types of log data and kind of looking at what normal looks like you say. That's the key, right? What does normal look like? And then if you know what normal looks like, then you can know when it's all screwed up, right? So yeah, that's definitely application layer. I mean, you could do something like this with web application logs. With any kind of application logs, you can do it with web server logs. And it's just making that analog, making the match between, okay, HTTP connect looks like this, and use this type of thing. And certainly you can use the stuff that's already there and make your own Arduino stuff. Yes, question? Question is, can you do multiple with multiple IPs on one machine? I don't see why not. I think you're limited by how many USB ports you have, I think, pretty much. You could fire up another Perl, CBPL or whatever, put the other IP in there and pipe that, because you do have the serial port on the end of the line that you're telling it which serial port to pipe that to. So you just line up whichever one you wanted with whichever serial port there was. So yeah, definitely doable. Any other questions? Okay, thanks a lot, guys. Have a good show.